The winter vegetable season is finally winding down a bit, and the spring melon season is getting underway. And now is an important time to review the insecticide chemistries that you may have used this winter, spring on produce crops, and those that you may consider using on melons. Sustaining long-term insecticide efficacy that annually provides cost-effective crop protection requires a conscious effort on the part of the PCAs and growers to prevent insecticide resistance. Since the early 1990s, the agrochemical industry has been actively developing and bringing to the vegetable melon market an unprecedented number of new chemistries that are highly effective, selective, and significantly safer than their chemical predecessors. This include the neonicotinoids, spinosins, tetramic acid derivatives, and diamides, to name a few. In the last few years, new chemistries have been added, including the sulfoxamine, Sequoia Transform, butenolide, Sivanto, and Torac. The development of new insecticide chemistries has slowed a bit, and older chemistries are continually being phased out of the marketplace. It was only a few years ago that endosulfan was removed from the market, and EPA is presently proposing a total ban of chlorpyrifos for agricultural uses. Thus, it is imperative to sustain the efficacy of the newer IPM tools currently available. Consequently, insecticide resistant management (IRM) is now more important than ever. The most fundamental approach to IRM is to minimize the selection of resistance to any one type of insecticide chemistry. Historically, alternating or rotating compounds with different modes of action has provided sustainable and effective IRM in our desert cropping system. The Insecticide Resistance Action Committee (IRAC), a coordinated crop protection industry group, was formed to develop guidelines that lay or prevent resistance. Using their most recent IRAC MOA classification brochure, we have updated a brief publication which provides insecticide modes of action on desert vegetables, and you can find this at the Arizona Cooperative Extension website. This publication also provides general information on the route of activity and pest spectrum for each chemistry. These classification lists will provide you with an additional set of guidelines for the selection of insecticides that can be used in desert IPM programs. You should note that Relief flunicamide has now been placed in a separate MOA category, Group 29, whereas in the past it was in Group 9B along with Fulfill, Pymetrozine. Now these two products with unique mode of action and similar pest spectrum can be rotated in an effort to prevent insecticide resistance. Thank you.